Today we're having a little look at a new sort of puzzle called a Slitherlink. Basically you're given a grid like this with, see there are squares formed by these dots, yeah, 1, 2, 3, 4. Look at that one in the bottom right hand corner. You'll see there are 4 dots surrounding a 3. Basically the number in the middle tells you how many straight lines there are in the surrounding square. So that tells me 3 of those 4 sides are connected. You can only connect a point to a point vertically or horizontally. You can't do them diagonally. Secondly, you must have one line going in and one line coming away from a point. So you couldn't have a situation like that, and you couldn't have a situation where you've got a single line going and stopping. It must continue, okay? Unmarked squares, they simply haven't told you how many of those are lines and how many aren't. So you have to work that out. In the end, this will make one big enclosed area on the way round, okay? It doesn't lead to separate areas, okay? So in the end, there should be, it should be divided. You'll see that there'll be one big area. Okay, let's have a little look. One of the things that helps with this is marking on where there can't be a line. For example, see there's a 0 there. That means none of these surrounding ones there can have a line on. So I'm putting a cross on those. They can't have a line on. But look, that tells me that, see this one says 3. The other 3 sides there, that's there, there, and there, have to be straight lines. Okay, we know 3 of these must be a straight line. We can't have one going out there though, can we? Because that would be more than one in and one away from a point. Okay, so that one can't be one, which means the 2 remaining ones must be there and there. Okay? Right. We also know there must be a line coming away from this one. We know it can't go up there because there isn't one there. So it'll have to go along there. Okay? Right. Next, we also know there can't be one there. That's got to come away from that. So that must go in that direction. There's only one there, which means that one can't be one, that one can't be one. This one was 3, so if that's not one, the other 3 must all be straight lines. And again, see it says 3, we can't have one going across there because there's one in and one away from it, so you can't have that one. So the other 3 must be like that. You know it can't just go there. It's got to continue across, it can't stop. So it must go across there. Now that's a 2, but you've got one there, so that one can't be one. Okay, if that one can't be one, this one's 3, which means that one, and that one have to be one. Okay? Now, you can't have one going up there because there's already one in and one out. So that's eliminated. That's eliminated. Do you see how this one here is a 2? That means that that one and that one are going to have to be lines. Okay. You know you can't stop there. So it can't join to that one because that would be sealing off a loop, and secondly, 3 lines joining one point. Remember, it can only be 2 lines from a point. There must be exactly 2 lines from every point. So that one's going to have to go up there. Okay. Now, this one, we know that can't be one there because look, there's one in, one out. So we know since that's a 2, that'll have to be 1 down there. So that can't be 1 there. So that means since that's a 3, it must go across there and go up there. Okay, now let's keep going. That can't stop there, so it must go up there. It can't go across there because there's already 2 into it, so it must go up. Must go up there. Okay, let's keep having a little look. Right. We know there's 1 here, but we don't know whether it's that one or that one yet, because, mind you, that can't join to there, can it? Yeah? Because if it joins to there, it seals off this loop. Yeah? So it can't join to there, so it must go across there, which means that one can't be 1, that can't be 1, and that can't be 1 because of the 1 there. Okay? Right, now if that can't be 1, that can't be 1 because there's already 2 going there, aren't there? You couldn't have a third one joining. So it means since that's a 2, that must go across there like that. Now neither of these can finish here, can they? So it must go up and it must go up. There's no choice there. That's what it had to do. Now look, that's a 2 there, yeah? There's 1 there, can't be 1 there, can't be 1 there, so the other one must go across there like that. Do you see how logically we're building up this big loop? Okay, so now we're coming to this one. We can't go across there because if we went across there, it would seal off this bit. Okay, and we know we can't seal off a bit. Secondly, we know that can't be 1 because look, that was a 2 and there's already 2 used there. So that means from here, we can't go across there, so it must go upwards. So that must go up. We don't know whether that one goes up or whether it goes across there. So we'll hang fire on that one for a minute. Okay. Now this is 3. So if it's 3 and it's in a corner, bearing in mind you can't end with just a line, that means that those 2 will have to be, and then there'll be 1 more out of that one and that one. We know there can't be 1 there. Okay, so either this one goes down and across there, or it goes across there and that comes across. But then that would have to go down and it can't go across there. So this one must go across there and across there. Right, that's the one, so we know that isn't 1. So that's going to have to go across there. And that matches that one. Bear in mind we can't seal off a bit, so it's going to have to keep going straight across, straight across, straight across. Okay. Now, look, we've got to there. This one can't go that way. It could go that way, but we need another one here. And it's not going to go like that. It's not going to go across there. So this one's going to have to go up there. Okay, which means we've got 1 more here. Can't be there, can't be there. So that one has to go like that. And to fill in the rest, to create the thing, it's going to have to go across there, down there, across there, down there. And that would be the shape. Do you see how it, when we finished, it's made 1 big loop. Now these are fairly tricky, but have a little look at these and see if you can logically work out them. Remember, this is just a puzzle. It's not important. I would like you to finish your quiz, but this is just a different puzzle called a Slitherlink. Okay, have a go at it, but don't worry if you find them too difficult.